All right, let's see. I think we're back. I think, yep, that looks like it's sharing just fine. Okay, so just a quick reminder if you're jumping back in. So I've got white, red, blue, green, purple, and orange as my colored chips. You can see the place value ordering right here. And let's, what are we gonna do this time? Multiplication. All right, let's do a couple multiplications. We can do any base we want. Really doesn't matter. Let's pick base 5 is what we're doing in class. So I'm just going to move these out of the way. Let's see. Maybe this time we'll do base, who cares? 6, base 7. Guess we don't do a lot with base 7. Why don't we try base 7? Okay. So base 7. So if I was going to multiply base 7 and I had something like 1, 2, base 7 multiplied by 3, base 7. Okay, so this is what I want to do. So what I do is I take a 1, 2, which would be 1 red, 2 whites. So there we go, 1, 2. This says I want to make 3 groups of them. So I'm going to take another 1, 2. I'm going to take another 1, 2. And again, I'm in base 7. So as I'm regrouping, I would have 2, 4, 6. I don't have enough to regroup. So I leave it as a 6 here and a 1, 2, 3. So I have 3, 6. And I would write my final answer as 3, 6, base 7. What's great about this is if there are no regroupings, the multiplication looks identical to what you would have in base 10. Once we have the regroupings, of course, then it's going to look a little bit different, right? So let's try this. And again, you can try this at home with your own set of poker chips, your own set of little colored tiles, whatever you have. Let's go on and we'll try the next one, right? 1, 2, base 7 times 4. Okay. So 1, 2. Okay, so now as I do this, I have 1, 2, 3, 4 groups of this, and each one of these gets 2. Okay, so there they, oops, it's not showing all the way on camera. Sorry about that. So 1, 2, 1, 2, 1, 2, 1, 2. I have 4 of them. Each one of these is 2. Each one of these is 1. So now as I'm regrouping, because now I have 2, 4, 6, 8. Well, that 8 is too many, so I need to take 7 of these, and I can take stack of 7 right here and pull those off to the side and regroup for one more of this red. So my final answer would be 1 of these ones and 1, 2, 3, 4, 5 reds. So it's going to look a little weird, but I end up with 5, 1, base 7. 5, 1, base 7. Now, if you're thinking about that, let's see if that makes sense. Okay, so 5, 1, this would be 5 groups of 7. That's 35 plus 1 would be 36 if we're thinking about this in base 10. And 1, 2, so 7 plus 2 is 9. So 9 times 4, 9 times 4 is 36. So that checks out. Numerically, it's the same values. Again, we're just writing them with different place value. Okay, let's keep going. Let's do one. I guess we could do a couple more. But I also want you to see, if you were looking at this, the difference between these two is like one more group of 1, 2. So if you were to just add a group of 1, 2 in here, you'd be able to go up one more factor. So from 3 to 4. So if you add 6 plus 2 is 8, which would be 1 with another 1 over here, and 1 plus 3 is 4, plus 1 is 5, so you'd have 5, 1. So it does check out if you were just thinking of just adding them kind of on paper. Okay. Let's see here. So if I was to do that, 1, 2, base 7 times 5 base 7, that looks fantastic. Again, it's like just putting one more group of 1, 2. Think about that, what we did with the chips. One more group of 1, 2 from what I already had would be 2, 3 total ones, and 6 here, which is 6, 3 base 7. Okay. And lastly, 1, 2 base 7 times 6 base 7. And let's see here. Yeah, so if I do that, I would just add another group of 1, 2. And 3 plus 2 is 5. 6 plus 1 is 7. So it's going to look a little bit different. So I'm going to have 105 base 7 because I regrouped. I finally had enough red chips. I had 7 red chips to get there. And lastly, let's do one more. Let's go up one more, which would be 8 times 7. So 1, 2 base 7 times 1, 0 base 7 is equal to what? Okay, well, let's do this one with the chips so we can kind of see it all the way through, okay? So I need 1 2s. Okay, so I'm going to put 1 red on top of 2 whites. So every time I see this, and you know what, the place value pieces here might actually just be a little confusing. So let me pull those out of the way. And I'll just leave a white piece of paper for contrast. Okay, so again, I want to make some 1 2s. So I take 2 white chips, 1 red, and I just kind of stack those into a pile. So when you see it sideways, it's going to be 1 2. There's another 1 2. Set that next to it. 1 2, 1 2, 1 2. And let's see here. And I had a total of 7 of these. So 1 2 3 4 5. I have 2 more here, 2 more here, and I'll grab 2 more red chips. Okay, so here we go. So this right here you can see is 7 groups, and each group has 1 red and 2 whites. All right. And what do I want to do here? Oh, I got to start doing some regroupings. So what I loved in class seeing is some of you would kind of take this and say, hey, let me just get all the reds out of the way. So there's all the reds right over here. And then start just kind of taking these whites and regrouping them by whatever base we have. And so my base is 7. So 1, 2, 3, 4, 5, 6, and 1 more would be 7. So this is a stack of 7. Okay, and I'll tip that sideways so you can kind of see it. There's a stack of 7. And what's great is, I'm going to hold that in one hand while I tip this other side here. What you'll see is it's exactly the same height as the other stack. So I have 7 in each of these stacks. And again, because I'm in base 7, 7 white chips whoosh, is equivalent to 1 additional red chip. And these 7 white chips are equivalent to 1 additional red chip. So I'm feeling pretty good about that. I got those reds here. You'll notice now I have a stack of red chips here, and I have 2, 3, 4, 5, 6, 7 of them, which makes sense. So 7 of these are traded in for 1 blue chip. Now, the reason why this is such an important piece of multiplication is whenever you multiply by the base, and notice my base is 7, and I'm multiplying by 7, which is in the form of 1 0, it looks exactly like base 10, and all it does is move everything over. So you notice now I have 1 blue, 2 reds, instead of 1 red and 2 whites. So this right here, this really is a 1 2. It just happens to be a 1 2 with one blue, 2 reds, instead of the 1 2 that I started with, which was 1 red and 2 whites. So again, if you look at this, I would have, when I multiplied this initial number by 7, I would have 7 of these white pieces, but 7 white pieces can be traded out for 1 red. And I do the same for the next white piece, which 7 of those can be traded for 1 red. And lastly, 7 red chips can be traded for 1 blue chip. So you can kind of see this is multiplying by the base, and it moves everything up by 1 color in terms of chips, but it moves them up in terms of 1 in terms of all the place values. So this is a very, very powerful piece. And if you really wanted to say, hey, well, what else could you do with this? Well, we could do 1 2 base 7 times 1 0 0 base 7. Okay, well, 1 0 0, think about your place values. That's 1s, 7s, and then 49s. Well, 49s are, if I had 49 of this red chip, that would be moving up 2 place values because it would be 49 higher. So those would actually be green chips. So the result of this would end up being 1 2 0 0 base 7, and multiplying by 10, what looks like 10, or by 100, which looks like 100, is really what we call multiplying by the base. In this case, the base is 7. Okay. So anyway, that's the idea here. So this is a super powerful idea, because now I can say I can do multiples of 1 2 quicker. So if they're shifted over, if they're in the what we would think of as the tens place, but now we're going to think of it as the sevens place because it's that next place. I can do multiplication quicker because I know that if I multiply by 7, I get a group that's one color chip up. Okay, so what does that mean? Now what it means is I can do something like this. I can do 1, 2 base 7 multiplied by, let's see here, 3, 4 base 7. Okay. So what do I need to do this multiplication? Yes, I really could come over here and say, okay, 7, so 3 times 7 is 21 plus 4 is 25. I could actually make 25 stacks of 1, 2. Like, literally, I could make 25 things, and every one of those things looks like this. So I'd have one of them here. I'd have 2 of them here. There's 2. I'd have 3. There's 3. And I just keep going until I have 25 of them. Then do all of your regroupings. There's nothing wrong with that. So this is like a Dr. Phil moment, okay? It's not wrong. It's just long. So it just takes a while longer. So let's instead think about what we did when we multiplied by a whole group of 7. See, over here, I'm multiplying by 3 groups of 7. So let's go and kind of think that over. So this 3, 4 would be like a group of 7, a group of 7, and a group of 7. That makes up 3 groups of 7, and then 4 of my standard. So what I would do is I would come up here and I'd say, okay, this 1, 2 is what I want. I want groups of 1, 2. But as soon as I multiply by the base, I get the next place value up, which would look like this. So this right here, we already said is 1, 0. So if I make another one of those, that's 2, 0. And if I make another one of those, that's 3, 0. I didn't want 3, 0. I wanted 3, 4. So I have 3 of this, and I now need 4 of these. So I would make a 1, 2, another 1, 2, make another 1, 2, and make another 1, 2. So what I have is 3, 4 groups that are all the 1, 2s. 1, 2, I mean, if you want to put it, they're all groups of 9, because that's what 1, 2 is. But when you look at it this way, they all look like 1, 2. So you could actually stack these up if you wanted to. The reason sometimes I like stacking them up is that I can visually see the 3, 3, 4. So I have 3 of this type, which is a 1, 2 bumped up, and then I have 4 of this type. So there's my 3, 4, and now it's time to do some regroupings. So let me get my blue chips over here. The rest of these are all red, so I'll tag along all the red chips, and let's see what we end up with. So I have some white chips left, 2, 4, 6. I have 8 of them, but I'm in base 7, so 2, 4, 6, and 1 more makes 7. Trade that for 1 more red and toss it in my red stack. Leaves me with 1 piece left over. Next up, I have 3, 4, 5, 6, 7. There's 7. I'm in base 7, so I'll do a little swapperoo right there. And there's nothing else to trade, so I kind of isolate these and lay them out so I can see them clearly. And I have 4, 4, 1, base 7 would be my final result. Okay. All right, so how could we do this without the chips? Could we do this without the chips? Okay, let's get the chips out of the way and we'll come back to it. Could we do this without the chips? Absolutely. Does this help? I can't tell if that's any better. Maybe it is. All right, I'll try with the light on when I'm writing these out. Okay, so if I want to do this, I would write my 1, 2. I would put multiply by 3, 4. 4 times 2, these are all in base 7. So 3 times, let's see here, 4 times 2 is 8. So that's 1 group of 7 and 1 remaining. 4 times 1 is 4, plus 1 more gives me 5. Now I'm moving in to multiply by groups of 7. So 3 times 2 is 6, and 3 times 1 is 3. Okay, and that should match. Notice it's 3 times 1, 2. We did that problem up here, and we got 3, 6. But because we're moving in to multiply by groups of 7, we have to move in by one place value. So that's why we get 360. Add these together, I get a 1 here. Let's see here, 6 and 5, that's 11. But 11 is one group of 7 and 4 ones remaining. And 3 plus 1 gives me 4. So there's another way to go about doing it. Using other pieces from the textbook, you could have done this with the lattice. So 1, 2 here, 3, 4 here. Make your grid and do your diagonals. Okay, let's see here. 4 times 2 is 8, and 8 is one group of 7 and a 1. 2 times 3 is 6, so I'd put a 0, 6. 3 times 1 is 3, 0, 3, and 1 times 4 is 4, so 0, 4. So as I look down the diagonals, I would have a 1 here. Next up, I'd have a 6 plus a 4 plus a 1. Notice that's 6 plus 5. That's exactly what I had in the base place, which would be the base 7 place. So 6 plus 1 is 7. That's a whole group of 7. That leaves me 4 remaining. So I have one more group of 7, and 3 plus 0 plus 1 gives me 4. So I end up with the same answer, 4, 4, 1, base 7. All right. So that's kind of how we do multiplication. Let's see. Should we try another one in base? Let's do another one base 4, maybe. Doesn't matter. Okay, so we'll do one in base 4. So why don't I do a 2, 1, 3? Okay, base 4. And I'm going to multiply that by, what do I want to do? 2, 1, 2, 2, 2, 2, 3, 3, 2, 3, 2. Okay. There's not a lot of digits in base 4. There's not a lot to choose from. Okay, so I want to multiply these out. Now, again, I could do the product on paper, and I can also show it to you with chips. If I was doing the chips, I would probably take this big number and say, show me what a 2, 1, 3 looks like. Okay, so I'm going to show you what a 2, 1, 3 looks like. That means I need 3 ones. There's the ones. I need 1 red. So there's the 1, 3, and I need 2 blues. So what I would have is a 2, 1, 3. Okay. Now that would be one of them. If I was looking at this number right here and kind of calculating, 4 times 3 would be 12, plus 2 would be 14. I would need 14 of this group if I was doing it the kind of the long way, the Dr. Phil, not wrong, just long approach. But this is a 2, 1, 3 right here. But since I'm multiplying by more, I've got 2 digits. Go to the second digit and say, what would it look like to multiply by one group of 4? And that's my base. So one group of 4, every white chip would become a red chip. Every red chip would become a blue chip. And every blue chip would become a green chip. So what I have is right down here, I have a 2, 1, 3. This is the standard 2, 1, 3. This other one up here is a 2, 1, 3, but it's listed by moving one place value in. And so this right here, 2, 1, 3, I'm going to stack it up. 2, 1, 3. So I'll turn to the side. You can see there's 2, 1, 3 right there. That's one of these that's moved in by one place value. I don't need one of them. I need 3 of those. So what I do is I take a look at my 2, 1, 3, and I make 3 stacks of that. So 2, 1, and 3. There's another stack of it. Put it right next to it. 2, 1, 3. And make another one. 2, 1, 3, because remember, it says in the problem I need to multiply by 3 of those larger groups and 2 of the smaller groups. So here's a 2, 1, 3 that's a smaller group. So I'm going to stack those up, 2, 1, 3. There's one of them. And then I'll make another one, a 2, 1, and a 3. 2 blues, 1 red, 3 whites. And those match up perfectly. So what I have now is I have chunks of 2, 1, 3. And I have 3 of the ones that are up one place value, and I have 2 of the standard size. And that's how I can see 3, 2 groups of 2, 1, 3. When I finish, all I do is take those and start moving, because I know I'm going to have to regroup at some point. So I'll put all my blues together, all my reds together. Greens are kind of sitting out over here by themselves. And there we are. So that's a pretty large chunk of chips. And remember, it's base 4. So I'm going to have some swapping to do as I go. So let's see, I have 3 here plus 1 more gives me 4. 4 of those gives me an additional red. That leaves me with just 2 white chips. Next up, 1, 2, 3, 4. And this is where if you're you push the stacks next to each other to find they're the same height. That goes 2 of these. And actually it makes a perfect third one. So I have 3 groups of 4 here. So each stack of 4 gives me another blue. Each stack of 4 gives me another blue, and each stack of 4 gives me another blue. So I just swap those in, make a stack of 4, make a stack of 4, and I've got a couple left over. So stack of 4 gives me a green. Stack of 4 gives me a green. Okay, so I'm looking pretty good here. And now 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that actually stacks up perfectly. Now, 1 stack of green gets me a purple. 1 more stack of green, 4 of them gets me a purple. So my final answer, this is actually pretty cool problem, because I have 2 in this place value, but at the end of the day, I don't have any more greens. Then I have 2 in this place value. I don't have any more reds, and I have 2 in this place value. So my final answer would be 20202. And this would be base 4. And that would be my final answer. If you want to do it using any of the algorithms, you certainly can. Maybe I'll do lattice on this one, but you can certainly do traditional. 2, 1, 3, multiply by 3, 2. And then I'll just make my diagonals. There we go. And then I can do the multiplication. So again, this is base 4. And I better write that down for myself so I remember base 4. 3 times 2 is 6, which is a group of 4 and 2 ones. That's 6. 3 times 3 is 9, which is 1 group of 4. No, 2 groups of 4, because that would make 8. And 1 left over. So 2 and 1. 1 times 3 is a quick one. That's a 0, 3. And 1 times 2 gives me a 0, 2. Lastly, 3 times 2 is 6. Again, 6 is 1 group of 4 and 2 ones. And lastly, 2 times 2 is 4, which I would write as 1 group of 4 and 0 ones. And then just add down the columns. This gives me just 2. I have 2, 3, 4. Well, that's a whole group of 4, so I regroup. 3, 4, 5, 6. So that's 6. That's a 2 and 1 more up here. 2, 3, 4. Gives me a 0 and a 1, and 1 plus 1 is 2. So I get 20202. And I feel like I'm in Veronica Mars with the 90909ers. That was one of the groups where she was living. Okay, so there it is. That's how you can do multiplication with the chips, and why place value, when you think about multiplying by groups like this, becomes really actually pretty nice when you're doing it. If you can think of that. So pick one of them and say, I'm going to make groups that look like this. And then this just tells you how many of each place value. The ones place look exactly like 2, 1, 3s. In this case, the 4s place, everything's just shifted up by 1 place value. And this tells me that I need 3 of those. Okay. So if I was using chips, so I'm sure some of you are like, well, can you use chips and do it quickly? Probably. So let's see here. If I was doing chips and I wanted to do another, I don't care, it doesn't matter what base it is. What base do you want to do this time? 6? Okay, so let's do 2, 1, 4, base 6. And I'm going to multiply that by, what do I want to do? 1, 3, 5? I don't care, base 6. So what I'm trying to make is pick one of them. I'll pick this one, doesn't matter. Pick one of them and make a 2, 1, 4. So make 2, 1, 4. Okay, 2, 1, 4. That's what a 2, 1, 4 looks like. There's a 2, 1, 4. But those are kind of in the ones place because they look exactly like a 2, 1, 4. When I move up to the next place, I need them to look one size bigger for everything. So the whites are going away. I'm going to have red, I'm going to have blue, and I'm going to have green. So now I have a 2, 1, 4 that's up 1 place value. Lastly, because I have 3 place values, I need one that looks even bigger than this. So I need this to jump up to be a 2, 1, 4, but I'm going to have to start with blues, then a green, and then some purples. So what I have here is 2, 1, 4, purple, blue, purple, green, blue. Next one over here is green, blue, red. So these are like my sandwiches. And there they are. So right here, this would be 1, 1, 1. So if I was multiplying 2, 1, 4 by 1, 1, 1, this is it right here. But I need 1, 3, 5. So I need not 1 in this middle, I need 3 of those. So I'm going to go make some more 2, 1, 4s. Okay, so that's 2 of them there. 2, 1, 4. And that's another one. So now I have 1, 3, and I need 5 of this last place value. So I need some 2s over here. So 2. Okay. And they all have to have a 1. So I pick 1 red and then 4 white. Pick 1 red and 4 white. Pick 1 red and 4 whites. Okay. And pick 1 red and 4 whites. All right. So here they are. So take a look. What do I have? Every stack looks like a 2, 1, 4. Every stack. These are my 1s, these are my 6s, and those are my 6 squareds. If this was base 10, these would be my 1s, my 10s, and my 100s. Just happens to be in base 6. Okay, so that would be what I would set up if I was going to do this multiplication. And then, yeah, I'm just going to kind of regroup to make all of my place values. And then I would start swapping things out as I go. So I want all the reds together, I want all the whites together. And I said this is base 6. So as I'm doing my regroupings, I am also looking for things that are going to help me. So if I was doing this with chips, what I do is I make a stack of 6. 1, 2, 3, 4, 5, 6. And then start making stacks that are exactly that size, because those are going to be your regroupings. They're going to be pretty quick as you do it. So 6, 6, and this next one's a little shy. Stack the column next to it. There's a 6. There's a 6. That one's a little bit shy as well. So I've got 2 perfect stacks and a little bit there. Roll this one over. There's 6. There's another 6. There's another 6, and I've got 2 left over. Okay, so now as I'm doing this again, I'm just making groups of 6 because I can see how quick it's going to be to start kind of swapping those groups out. Ah, my leg's falling asleep. Oh, let's see here. So I have 3 groups of 6 that I can trade out. So 1, 2, 3 of those gives me 1, 2, 3 additional groups in the next column. It does leave me with 2 additional singles right here. I have 3 of these groups that are stacked up in 6s, so I can shove those off to the side and give myself 3 blue chips. Okay. 3 of these stacks, they swap out. Each one of them steps out for a green. So I take 3 greens, put them into my stack. I have 1 stack of greens ready to go. I swap that out for 1 purple. And my final answer becomes 3, 4, 2, 2, 2. So my final answer here, if I was doing this, would be 3, 4, 2, 2, 2, base 6. And yes, if you want to do this, you can check yourself really quickly using the lattice, or you can use the standard algorithm. Totally up to you. The lattice, it's not bad at all. You just have to write stuff out. You have to draw the boxes. So why don't I do the standard algorithm for this one and make sure that we can do that. 2, 1, 4, multiply by 1, 3, 5. So again, these are all base 6. So 5 times 4 is 20. Well, 20 is 3 6s, because that's 18, and 2 remaining. 5 times 1 is 5, 6, 7, 8. That's a total of 8, which is 1 group of 6 and 2 1s remaining. And 5 times 2 is 10, plus 1 is 11. 11 is 1 group of 6 and 5 1s. There's my first row. I'm now multiplied by 5. I move in to multiply by 3 groups of 6, and since I'm multiplying by group of 6, I will not have any 1s anymore. So 3 times 4 is 12, which is 0 and 2. 3 times 1 is 3, 4, 5. Oh, that works out pretty nicely. 3 times 2 is 6, and I would just write that as a 1, 0. So I'm done with the 3. Now I come over to the 1, which is in the second place value over. So I won't get anything in the first because of the way I'm multiplying. And I get the 1 basically times a 2, 1, 4. So I'd have a 4, a 1, and a 2. And then I can just add these together. So I end up with a 2, a 2. Take a look here. 5 plus 5 is 10. 10 plus 4 is 14. Well, 14 would be 2 groups of 6 and 2 remaining. Next, I have 2, 3, 4. And lastly, 2 plus 1 is 3. So I get 3, 4, 2, 2, 2. That matches exactly what we got with the chips. And the world is a happy place. So that's multiplication with the bases. Again, when you start seeing it kind of as those groups that you can make the stacks of it, it becomes really, I think, much quicker than trying to make all of those stacks. But either way works. Not wrong, just long. All right, off you go.